path with maximum probability says that you need to go from a point of a start node to an end node such that the end node and start node are given in the question. Over here it is start is 0 and the end is 2, so these are my start and end nodes, such that I need to find out some way, some path, either this or some path through which the probability is maximum. What is probability of two things? So P1 into P2 is the complete probability if there are two P's in the path, right? So that is our P, and this P should be maximized in our question. Two things. Why Dijkstra will work over here? So Dijkstra works on both single source, shortest path, single source, longest path, but it just does not work for negative cycles, right? If there is a negative cycle, then it won't work. Over here, same way, if there is some positive cycle, then it might start failing, right? Because we have to just increase the number and it will keep on increasing, right? So if there is a negative cycle, it will fail over there. If there is a positive cycle, it will fail over here. But if over here we consider that there is nothing like plus and minus, now over here we can just consider that every node's probability at first is maybe 0 except the first one, which we can surely know that we can reach over there, right? So let it be 1, and the other nodes can have 0 0 as their probability, right? So now when we go from one node to the other, we know that its probability will become the edge weight into this probability. Now if this probability is greater than 0, which it will always be, we can just update this probability to 0.5 and then push this into the priority queue, the same way the Dijkstra works, right? And then we can do this for till we reach the end node, and as soon as we reach the end node for the first time, we can just return whatever the value end node's distance has. End node will have some distance value, right? Distance is the P value which we considered, like P1 into P2 into so on till Pn, if these nodes are in the path to reach there till P of end node. So that is that. Now why this will work even if there is a cycle? So first thing is that we don't need even a visited node over here, because even if there is a cycle, the first time we encounter something, right, we are just eliminating this end node and we are just printing out the answer if we reach the end node. First thing. Second thing is, when we are going through a loop, the value is never becoming greater. So suppose if I am going from 0 to 1 to 2, right? So from 0 to 1, the value became 0.5 for 1. From 1 to 2, suppose it became 0.5 into 0.5, which is 0.25. Now into 0.2, which will become, it was already at 1. So this will never consider the value of 0.25 into 0.2, which will become 0.0405, I guess, right? So this will never replace this, and this will never go into the priority queue also. So we can safely say that the cycle, infinite cycle thing will never happen, which is the main downfall of, the con of Dijkstra, which it cannot handle, right? Generally, if there was a negative cycle in single source shortest path, right, the same problem we face, that there was a negative cycle. Then if it goes on in this cycle, we can just say that its distance will keep on decreasing, which means that it will go on an infinite loop, which we want to avoid over there. Over here also we want to avoid it, right? But here there is no need of avoidance, because this infinite cycle will never happen, because what we are considering in the beginning is the lowest values of probability, which is 0, and probability ranges from 0 to 1, and the probability will always go from 0 to 1 in a monotonic fashion. It will never decrease as such. Like we have given the condition that it will never decrease for our Dijkstra's, modified Dijkstra or Dijkstra, whatever we can call it. We can just look at the code. First we make the graph. I faced runtime errors because of this. This n was already defined, and I was defining n as edges.size again, and then over here when I was taking that I is less than n, it was considering those values and trying to put it in when the edges value is less than n. So the edges can be less than n, right? Over here in the one of the examples only, you can see that if there is this kind of a thing, there is only one edge while there are 3 nodes. So n is 3 while edge is only 1, which means that length is equal to 1 only. So I was trying to access this out of bound index, and it took me some time to figure out what was the issue, because this n was already given in question, right? And I took the same variable name, so that was a pitfall that I was doing. So, and it was a 0 indexed graph. So normally however we make the graph, it is the same thing. We are making the graph, then in the like a single source shortest path Dijkstra we are doing here. We declare distance array, which is the probability basically. Then we mark the first one, whatever the start node is, the probability of reaching that start node equal to 1, because 100% we are reaching there because we are starting over there. Then we define a priority queue. In the priority queue we push that the start node, and then we start this loop of the non-empty priority queue loop, so that now over here we can just take out the first element from the priority queue, then try to insert all of the, and if that element itself is the end node, then we can just return the distance, because this happens because the first time element goes out of the element goes out of priority queue in Dijkstra, it defines that it is the shortest path for it has been calculated. We know now for that node it will never go below that. In this case it will never go higher than that, right? So we are just considering that each of the neighbor we are, so from 1, if we have 2, 3 and 4, we are going to 2 first. We are checking if the distance of 2 is actually lesser than this p1 into the distance of 1. So p1 into distance of 1, if this value is greater than d2, then we will replace d2 with this value and then push this into the priority queue. Then we will do the same for this, and then in the next iteration we take out something from the priority queue. We choose all the values whatever can be chosen in the step, and then priority queue helps us make the best possible choice instead of a queue. Queue can also be used, but we'll use the priority queue, because all those worries wherein we have to, because in a queue, right, queue also will give us the answer, but we'll have to do some more operations will increase in a queue implementation of Djikstra, so we won't be going that way. So just pruning the solution, this is just pruning our possibilities, and hence giving a better time complexity. Not exactly complexity if you consider the big O notation, but it will take lesser time when compared to the queue implementation, less time. So we just push it into the queue, and then we return 0 if there was like some disjoincy is there, right? If we say that the start node is this and end node is this, the probability maximize, how can we do that? We cannot, right? We cannot reach from this to this, so we can just say that it was 0 as such.